So in this video, we're going to answer question 2 and question 3 of Math 2100 Analytical Geometry and Calculus question. So the question reads, the orbit of the Earth is an ellipse with Sun at one focus. The planet's maximum distance from the Sun is 94.56 million miles, and its minimum distance is 91.44 million miles. What are the major and minor semi-axes of the Earth's orbit, and what is its eccentricity? So we are asked what is the major and what a minor axis of this Earth orbit, and what is its eccentricity. So now, before you are able to answer that, you have to get a graphical representation of what they're actually talking about. So let's consider our x or y plane like this. Then they are told that the orbit of the Earth is an ellipse. So I'll draw an ellipse here like this. So okay, that's not up to scale properly. Let me try to draw something that's up to scale. Okay, use this tool there. Then okay, so okay, I think this one is better. So we're told that the Earth, the orbit, the Earth's orbit, or the orbit of the Earth is what? Is an ellipse. Then they're telling you that with the Sun at one focus, and so we're told that the Sun is at what? Is at one focus. So now, since it's an ellipse, we know that it will have two what? It will have a foci. So there will be two. So let's say you can have one here. Let's name this F1. Then you can have another one here. Let's name this F2. So they're telling us at one of these focus, you have what? You have the Sun. So let's say the Sun is here at F2, like this. I'll draw this is the Sun. So the Sun is here. And they're telling you that the planet's maximum distance from the Sun. So remember, so the Earth, this ellipse here is the orbit of what? Of the Earth. So let's say the Earth is what is here. It's here. Remember, this does not mean that the Earth is just stationary here, but it continues to move because this is the orbit. If it moves like that, it will continue to move like that. I don't know if it moves clockwise or anti-clockwise, but whatever, it will be moving in this what? In this path here, which is the what? Which is the ellipse. So now I told this here, this green here, we indicate it to say this is what? Our Earth. So that is our Earth. And now they're telling you that the maximum distance. So maximum distance, maximum distance from the Sun is what? Is 94 million, 94.56 million. So now you see the Sun is here at F2. So if this Earth continues to move and let's say it touches here, so we see that this here, the distance from here up to the Sun is going to be the maximum what? Distance. So this distance from here all the way up to where the Sun is, this distance here is bigger than what? The distance from here to this part here. So we see that when the Earth is here, then this here will be the maximum distance. Then we see when the Earth is here, this will be the minimum distance from the Earth to the Sun. Then there from of course here the Earth to the Sun, that will be the maximum distance. So we name this. So I'll name this first part as D for distance. Then I'll say max. So for maximum distance, then this other part for D mean as minimum distance. So that is what I'll name them. Then now I know that so from here, let's say this is where let me do a dotted line here where my Earth is, like that. So the distance from So here is the origin, which is, let's say, 0, 0 there. So the distance from this origin to where the focus is, of course, even up to there, it's just the same. You have this distance is just given by c, which is a point for the focus. Then from this origin to all the way where this vertex is here, that distance here is given by what? By a. And that distance now is, in this case, if the ellipse, since the ellipse sits, we've put it that the ellipse is sitting in the major diagonal, so it would mean that there is going to be the a, which is going to determine our major diagonal. So this is just the distance from the center or the origin to the vertex there. And of course, it is the same from here up to this side here. It will be a as well. So the entire length of this, from this point to where this other point is given by what? To a. From here to there is c. So now from one vertex to the next, I mean from one focus to the next focus, that distance between there is just 2 what? To c. Okay, so this is how it graphically looks. So now, after determining how it graphically looks, how are we going to now find the other thing? So now we have to find the major the major axis is what they are telling us to find. So now remember, we said from here to there, this distance is the distance is the distance a, and so we have to find that distance a. For us to find our major axis, we have to first find that distance a. So how are we going to find that distance a? So now we can note here, you can see that the distance, the maximum distance, this maximum distance from here to there and from there to there is just what? The 2a, which were what we're talking about. So when we divide then by 2, means we just get the distance from here to where that is, and that is our a. So we say the major axis, major semi-axis, of course, major semi-axis is going to be a equal to, so you say the maximum distance plus the minimum distance, then divided by 2. So when we equate that there, what we're going to get is, so now you substitute, you've already been given your maximum distance is this 94.56 million miles, and that I can write as 94.56. So the million, I write this in terms of scientific notation, so that we multiplied by 10 to the power 6, since it's a million. In a million, you know, there's 6 place values like of the zeros there. Then from here, I also add the minimum. So the minimum is what? 91.44 multiplied by 10 to the power 6, since it's a million. Then divide this by what? By 2. Okay, so after getting this, so when you punch in your calculator or you add these on top, you'll be getting you get 183.6 multiplied by 10 to the power 6, then divided by what? By 2. Okay, so I'll be rounding them off in advance. So I have 93 multiplied by 10 to the power 6, and this is what is miles. So in short, you have 93. So that is 93 million miles. That is that distance of what? Of a there. The distance of a is given by that. So now, what are we going to get? And of course, that is our major That's our major axis. This major semi-axis of the orbit is going to be this 93 here. Now we have to find also the minor one. So to find the minor axis now, what we have to do is we first must find our c. So we have to find this C here. So the minor one, so if you have the major sitting in the X and it's A like this, the minor one in this case is going to sit in the what? In the Y. And it will be the distance from there to there like that. And this here is given by B. So that's what you're going to get. Now we found A, so meaning we can find, and here we can also find C. Then we can use the formula for the ellipse to then find our to find that part, our B. So what are we going to say? So we're going to say that C, so we first find C here, such that we have A and B. So if we have A and C, then we can easily find what? We can easily find the B which we want. So observe here that our C, the distance from here to where that focus is, or the distance from here to where that other focus is, you see that that is just going to be, so when I subtract, uh, since this distance from here to there, from this focus, this minimum distance is the same even from this point towards to where that focus is. So if I subtract that, meaning the distance that I'm going to remain with, you have that distance from here to what? To where the focus is. So you have the distance from here to where, from one focus to the next focus. So in short, you're going to have the distance of the two foci, so which is just 2C. So you have the 2C there. So if you subtract this part, say this part goes, so the distance from here, in short, what you're remaining with, if you subtract that minimum distance, you remain from distance from there. Yeah, so the distance between these two dotted lines, that's 2C. And that is what you use to find your C. So now, meaning our C is just going to be the maximum distance. You subtract the what? Minimum distance. Then, of course, since it's 2C, you divide by what? Divide by 2 there, because we are just interested in what? In C. So, and then when you replace this, you have 94.56, then multiplied by 10 to the power 6, then minus 91.44 times 10 to the power 6, like that, then divided by 2. And you're just going to get that C will be equal to, so that will be 3.12 multiplied by 10 to the power 6, then divided by 2. And this here just gives you 1.56 multiplied by 10 to the power 6 what? Mouse. So this here is going to be our distance C. Now, after finding our distance C, meaning we can now find our B value, which is going to be the minor semi-axis. So how do we do that? Now, because this is an ellipse, we can say that our B, and it sits in the what? In the x-axis, we can say that our B is just equal to root of x squared minus what? C squared. So now, since we already have A and we have C, we can just replace this in our formula since we found that. So our A was found to be 93 by what? 10 to the power 6, then minus, we just found our C to be 1.56 multiplied by 10 to the power 6. Of course, I should not forget to square this like this. Then I can compute this, just press that in your calculator, and you just have 92.9, you have 92.987 multiplied by 10 to the power 6 mouse. So this here is going to be what? Your B, and this B here, this is what we're calling our minor semi-axis. So this is our minor semi-axis. Okay, so that's our minor semi-axis, and because it is also centered at this here is centered at 0, 0. So if you're going to write it in terms of either negative or positive, because you know that the distance from here to there is the same from this vertex to the center, and that's there to the center. So now this is telling you that the distance from there to there is going to be this. So if you write it as coordinates, meaning in the x, of course, it's 0, but in the y positive there, you write this number which I'm finding, 93.987 multiplied by 10 to the power 6 million mouse. Then for this down here, this part here, it's the same 0, but just this will bear a negative 3.987 times 10 to the power 6. So that's how you write it in the coordinate form. But already finding this, you understand that that is your your minor axis. Okay. Now the question does not end there. The question also wants us to find the eccentricity. So eccentricity, how are we going to get that eccentricity? So we know that eccentricity is just this is just given by the formula. So eccentricity is just given by the formula E to be equal to what? C over what? C over A. So C over A, that is going to be our eccentricity. And we found C and we found A. So we can just replace that. We have 1.56 times 10. So that is 1.56 million divided by 93 million here. And what you get is 0.016774193. Then I can round off this to just 0.016718, like that. So this is going to be my eccentricity. And from this, I've gotten that my eccentricity, it's in between eccentricity is in between 1 and 0. So this confirms that this is this is an ellipse. For an ellipse, it's always between 1 and 0. Then we have that for so you have the hyperbola, the eccentricity is going to be greater than what? Than 1. Then for the parabola, the eccentricity is going to be what? Eccentricity is going to be equal to 1. Yeah, something like that. Not equal to 1, then less than 1. Kind of not, yeah, not something like that. So this is what you'd get. Unless there's any question on how we found or worked out this question. All right, since there's no question, let's move on to this one. So this one says, identify the particular conic section and give its eccentricity and the shorter distance of the directrix from the origin. So now for this here, question is given like this, where in terms of R, you must notice that the general form of this, and for this question given, is going to be EP divided by 1, so minus E sine what? Sine theta, where E is the eccentricity, and P is just the distance from the focus to the directrix, the distance from the focus to the directrix. So other versions of it is going to be EP over 1 is what 1 it's 1 plus E sine theta R equal to EP, that's 1 minus cos E cos theta. Then the other one, of course, you know, to have what? To have plus. All right, so now as the one they've given us is like that one, the first one. So now here, what we have to find is they're telling us identify the particular conic section and give the eccentricity and the shorter distance of the directrix from the origin. Then they are saying here, state the equations of the directrix, the focus, and the coordinates of its intercepts in polar coordinates. So now first you have to identify what this is. So how do you identify? So to identify this particular section, you have to put it in a standard form. So you have R 4 over 2 minus sine theta. So now what you do here, you have to put it into this standard form where you have a 1 here. So now I'm going to say 4, then Then I can factor out that 2 there, such that I have a 1 minus what? There's a 1 in front of the sign there. So meaning that would be half sine theta. So you have that there. Then you say that this is going to be 2 over, so these 2 can divide into the 4 such that you have 2 here. Then you have 1 minus half sine what? Sine theta. So this is what you're going to get. So now, after getting this, you can actually now identify what type of conic section this is. So how do you identify? So this number in front of the sine theta, this is what is E, and that is your eccentricity. So your eccentricity is going to be half. And since it's half, half is in between 0 and what? And 1. So this means that this will be an ellipse. This is going to be an ellipse. So now, so we've identified one, the conic section. So cancel out that one. Give it eccentricity. We found the eccentricity is half. Then now, let's find the shorter distance from the directrix, which is given by EP. Since we say this P is the distance from the directrix from the what? From the origin. So now you're going to say EP is equal to what? EP is equal to 2 in our case. So equal to 2. We know our eccentricity is half. There I can replace. And when we just make here multiply by 2 both sides, we just have P is equal to what? To 4. So this is the distance from the what? From the origin to the directrix. So we found that other one. Now let's get to the other part of the question. So the other part, again, let me erase this. So the other parts now demand that we should find the equations of what? Of the directrix and also the foci and what? And the other coordinates. So now, how are we going to do that one? So we first have to what? We have to graph this. So now, in order to graph, we have to get points. So how do we get those points? So now, to get those points, we have to set values of what? Of theta. So let's say I have theta here, then I want to be seeing what values I'm getting out of there. So my theta, I'll write it in first of all where you have, this is like 0, 0. So I'll be writing it in radians and also in what? In degrees. But when you're using here, we'll be using what? When graphing, we'll be using radians, not the degrees. So now 0. So this 0, what you do is, remember this equation which we've been given. Let me erase this. So you have been given r is equal to 4 over 2 minus sine theta. So now after you replace your 0 where the theta is. Then after replacing your 0, you find that value of the value of r which you'll be getting. And when you replace sine 0 is just 0, and you just have 2 divided by 2, which is 2. So you get 2 there. Then the next one, you have pi over 2, which is 90. So replace there, you see that you get, this will just give you, sine 90 is 1. So 2 minus 1 gives you 1, then that will be 4. So you get 4 there. Then you have pi, which is 180. Do the same, you get 2 there. Then you have 3 over 2 pi, which is 270. Then you get 4 over 3. Then the other one is just 2 pi. Then you have, that is just 360. So it's the same as 0. And that will give you what? To give you 2. So, okay, you just end in this cycle here since you just sketching for the values there. So now, what next do I do? From here, you now sketch and you use the same, these coordinates. So now, this, because it's sine, so when it's sine, it means that whatever shape you're dealing with is in the what? Is in the y-axis. If it's cos, then it's in the what? It's in the in the x-axis. So now from there we have that, then like that. So now we say this is our x, that's our y. This is our y. So now what are you going to do? So you have this at 0. So at 0, what point are you going to get? It's 2. So meaning, so 0, this 0 here accounts for, it's in the x. So meaning that's 0, it's 0, 0 meaning in the x we're not moving. I mean in the y we're not moving. Then we have what? We have the value of what? Of 2 there. Then here you have when it's 90. So we know from here. So if you're moving from here to there, this is a 90 degree. So when we reach here, it will be 90 degrees. So that is going to be at 4. So you have that at 4. That's 2. Then this side also, when you do a 180, this is at 2. So, but we know that this is what going to be negative 2 since it's in the negative region. Then there you're going to have down here negative what? Negative 4 over what? Over 3. Negative 4 over 3 since it gave us 4 over 3. But we know 270 is just is in the negative region here. So now if I join, and at 360 it's still at 2. So if I join these, I'm going to have that there. Okay, this might not be drawn up to scale properly, but like that, you're going to have your ellipse like this, something like this. So this is going to be your ellipse, and now you know you have to label this ellipse. One of the focus when you're dealing with these rotations, one of the focus is always at the what? Always at the origin. So we know that focus 1 is here, the at origin, which is 0, 0. Then now the distance from here. So now what you use is the distance from this focus to this vertex here is this 4 over 3. That's the distance. So it means that the distance from 4 here, when we subtract 1 over 3, gives us the next what? The next vertex there. So F2 is just going to be there. And we know this is going to be at 0, comma. So when you subtract 8 from there, you're going to get, I mean 4, you subtract this 4 over 3, you just get 8 over what? 8 over 3. So this is another what? Other focus. Then now you label these vertexes, these vertex that you have. So how are you going to label them? Here you know that you're moving in the what? In the y. So in the this 4 is in the what? Is in the y. But in the x, we're saying you moved at what? At pi, then 4. Then there you moved here. It's what? It's going to be. It's cutting in the x. So it's cutting in the x here. So if it's cutting in the x, what does that mean? It means in the y you're not what? You're not moving. So it cuts at 2, comma what? Comma 0 there. Cuts at 2, comma 0. Then same here, you write and you label that as negative. So here, where is it cutting? This was at an angle of what? Of 3 over 2 what? Pi. That's radians, of course. Then and your y, your x, I mean your y value where it's cut is at negative 4 over what? Over 3. Then on the other side here, that you know your x, it's negative what? 2, and the y is just at what? At pi, since it's 180 degrees. So this is how your focus is going to look. Okay, so apart from that, now you can answer these other parts of the question, which is your directrix. For example, they tell you your directrix. So your directrix, we found that the distance there was what? Was p, and the p was equal to what? To 4. So now your p is equal to what? To 4. So, and so yeah, so the p that we had is equal to 4, and of course it's at saying at pi over what? Pi over 2. So the directrix always cuts in the opposite like this. So it's going to be here, which is going to be at pi comma negative what? Negative 4. So this is going to be what? I mean pi over 2, not pi, but pi over 2, negative 4. This will be your directrix there. So we found that our p, our distance was what? Was 4. So, but then we know that if it's in the y like this, And if it's in the y like this, maybe if you see it from the focus. So from the other focus, which we found that first we had 0, 0, then the focus was 0, 0.83. Yeah, so these are the two focus which answers this part of it. Then on the other one, the on the so this answers this part, we've already answered it. Then on the now on this directrix, we also found it as p over 4, that's the distance, p over 4 what over 4 units. So now p over 4 units from the origin. So now when you look at here to where we went here, this here was the what was the vertex. So now, but then we know that it has to be in the opposite of what of that vertex there. So meaning it has to be negative units down there. Then for the intercepts, you're going to now. So the intercepts is where this is cutting. So and they're telling it right in polar form. So where this ellipse is cutting the x. So for the x-intercepts, it's going to be that -2, pi, and that pi, what, 0. This will be your intercept since it's cutting there. Then for the y, where it's cutting, it's at pi over 2, 4, and then the other one is just the other one is 3 over 2 pi, then -4 over what over 3. So this here will be your y-intercept. Okay, so this is how you answer this question, unless there's any other question. But we are done. Okay, since there's no question, then we end here. See you in the next class.